Thanks, Mark. Well, where to start in the turbulent times in which we all find ourselves? So space has always had a fundamental role to play in defence, whether that's secure communications, intelligence gathering, or position navigation and timing. And increasingly in recent years, we're seeing that the role of space and its importance to defence and through that global security has never been more pronounced. And the inverse is also true. We're seeing across our portfolio and across the broader SpaceTech ecosystem that defence customers and governments are really one of the primary drivers of the significant growth that the sector is exhibiting. So I'm delighted to have with me today two representatives from two of the portfolio companies that I'm personally privileged to be involved with. So first of all, welcome to Steve Young, Head of Satellite Missions at ICEYE, and to Paul McCarter, CEO of ALL.SPACE. Thank you both for joining me here today. I thought a good place to start would be to give you each the opportunity to introduce yourselves and tell our audience a little bit more about your respective businesses. So, Steve, if you wouldn't mind starting.
Sure, James, thanks very much. Pleasure to be here, and thanks to Seraphim for organising this today. Steve Young, the President of Satellite Missions at ICEYE. My background is in physics, engineering and so on. Spent most of my career in the aerospace, defence and space industry, predominantly on the commercial export and sort of business development type side. Over the last 5 or 6 years, since joining ICEYE, I've been incredibly impressed to see the developments made in ICEYE. ICEYE is an organisation which was founded off the back of a innovation in radar technology made at Aalto University in Finland that has enabled low-cost but high-performance radar satellites, in fact SAR satellites, as referenced by Mark in his introduction, to be made, and that's enabled us to deliver a constellation of small radar satellites. The reason you need a constellation, which is many satellites orbiting the Earth at once, is to enable you to have very fast revisit times, meaning you can see anywhere on the planet very, very quickly and very often, several times an hour, for example. And that gives you the ability now to really look at a whole different range of applications that were never available before that, and provide data and insights, for example, as Mark mentioned, into flood events, or indeed in the context of what we're talking about now, defence and security domain. So it's really proved to be something that was never available before this innovation happened, and that's been evident in ICEYE's growth over the last few years.
Great, thanks very much, Steve. If you don't mind passing the
Sure.
microphone over to Paul. Paul, welcome. If you wouldn't mind just introducing yourself and giving a brief overview on ALL.SPACE.
Good morning, James. Paul McCarter, Chief Executive of ALL.SPACE. My background, also an engineer, not surprising given the technology we're all using, but software engineering. I started off my career with 12 years in the military, and for the last 25 years I've been running global or national technology companies, mostly around R&D and bringing new innovative technology to the markets. About a year ago, I was asked to come join ALL.SPACE because they'd reached a pretty seminal point on the technology they'd been developing, and they wanted to expand that and make it go global, and therefore they're looking at that next global step of how they expand the technology to different markets. What ALL.SPACE does is about 10 years ago they recognised there was a huge amount of investment into the infrastructure in space. Geo technology was therefore being introduced for MEO technology and LEO satellites. And the huge amount of proliferation of networks in space meant there was a huge amount of different networks with different modulation schemes and different connectivity, depending upon where you are on the planet and depending upon which network you want to use and how much bandwidth you want to use. The founder, John Finney, who started this 10 years ago, recognised the fact that whilst the investment in space was huge, having an antenna that could work on the move, that could act as a terrestrial hub, be it on land, sea or air, that could connect to all of the networks in space, no matter the frequency or the orbit they're operating in, was going to be absolutely pivotal for providing an all-space communications platform. And he set about finding a way of doing that. The technology that he found that would enable him to do a communication channel to more than one satellite in any orbit was called transformational optics. And the capability therefore was patented and therefore enabled the electronics communication to go simultaneous, multi-orbit, multi-beam links that nobody else currently in the world can do. Now, whilst we look at this for a development on any market, and it can be used in telecommunications, it can be used in B2C marketplaces, one of the real needs that we have at the moment is in the defence sector, where you look at the capability that's being asked for to connect to anywhere on the planet, simultaneous links just in case you get jammed, or just in case you need to use multiple networks for different reasons and different uses. Having the ability to connect to more than one satellite simultaneously is extremely useful from a resilience and a diversity perspective, no matter where you operate on the planet. And that has been picked up by not only the NATO militaries, but very much the US militaries who are partnering with us to invest in this and diversify it and move past what we now have as the first product in the market space.
Thanks very much, Paul. I'm going to stick with you for a moment, but I've got a particular topic I wanted to get both of your views on. I thought it'd be helpful for the audience to perhaps look specifically at the conflict in Ukraine and how that has changed the landscape of defence more broadly, but specifically the way in which governments are looking of availing of satellite capabilities, and particularly those from emerging companies such as your own. So, Paul, for example, it was widely reported that one of the first things that the Russians did at the point that they invaded Ukraine was to interfere with the Viasat constellation that the Ukrainian military relied upon. More recently, we've seen electronic warfare interfering with at the Starlink terminals that have been deployed. So I wondered if you could just give some observations from a SATCOM's perspective and from ALL.SPACE's perspective, how the conflict in Ukraine is changing the way your capabilities are used and needed by governments.
Well, I think one of the key things you've just brought out is that point about resilience. If all you can do is connect to a single satellite at a time, even if you have the ability to switch and you don't have two satellite connections, if somebody takes away or denies a single satellite connection, you have to reacquire and go through a process of connecting to either any orbit satellite again. And it might be that it's denied locally on the ground rather than denied in space. So the first thing is you have to have the ability for diversity. Otherwise, if communications is taken away from you, in a military warfare context, then you don't have the ability to either get your position, navigation and timing, or your communication and coordination throughout the whole of the military network, which is vital in today's world when you're trying to do that. Secondly, though, and I think when you look at dual use types of capability, so in this particular use, Starlink, which has led to Starshield, or Viasat, when you look at the amount of investment that goes into a particular product, be it a commercial product, normally you wouldn't necessarily invest into those things that make it completely resilient to warfare and the expected capability in a warfare environment where it would have to resist jamming or have the ability to deal with the types of environments that military operations require to work in. So the investment in things that would therefore work specifically for defence takes a little more from the regulatory perspective, but also the military specification. And therefore, that crossover, when you look at dual use capability, is very important to consider if you're going to deploy assets into the field to use and enable the warfighter to keep the pace of war going.
Thanks, Paul. I'll just build on that, and then I'll ask Steve to chime in. Do you think it's fair to say that in terms of the way that the conflict in Ukraine has unfolded, that in terms of you've referred to SpaceX and Starlink, their mega constellation, that this has now demonstrated to governments the central role that these very large constellations of small satellites now must play in their connectivity solutions?
Yeah, absolutely. What they're really asking for is ubiquity. What they really need is the ability at any moment in time in any geography to connect to more than one orbit and more than one satellite operator. So the fact you've now seen LEO constellations with Starlink, and then you've got Amazon Kuiper and Telesat Lightspeed to fast follow, it's created the opportunity for them to utilise both. And be it in the Ka band frequency or the Ku band frequency, what they urgently need is the ability to connect to any one of those networks. So your point is perfectly made. If you have that ability, it gives you flexibility to use all the communications to connect into your theatre-wide communication systems. One point that Par made about utilisation of different networks and capability. And therefore, if you have that and these constellation networks, why wouldn't you use them? And why wouldn't you want the ability to connect to them? That's why we're focused on ALL.SPACE, because the terminal that we've created makes that a possibility in the warfight.
Great stuff. Well, more on that in a moment. So, Steve, over to you. Similar question about Ukraine. It's in the public domain that ICEYE has played a fairly central role in supporting Ukrainian efforts to resist the Russian aggression, including the provision of imagery to the Ukrainian military. So I just, again, interested in your observations about the extent to which Ukraine has been, from a sort of Earth observation and intelligence gathering perspective, a watershed moment in terms of demonstrating to governments the unique role that large constellations of small satellites, such as those produced and operated by ICEYE, can play and will need to play going forward.
Sure. Yeah, as you said, James, absolutely. ICEYE has supported Ukraine since the very beginning of the crisis, and it has really highlighted the need for an independent, often independent source of Earth observation data. And the synthetic aperture radar SAR satellites have played a pivotal role in this over the last few years, not least of which because we can see at night, we can see through cloud, we can even detect, for example, metal objects under foliage and so on. So it's been an invaluable tool for the Ukrainians to really understand or get what is often termed situational awareness. What that has done has driven a huge demand, often supported through the US and through the UK, for as much imagery and data as we can collect over the region. And back to my original point in the intro about the need for many satellites so you can get the very, very quick revisit times, which means you've now got a system which has changed satellites from being what used to be a strategic asset, so big government, one or two satellites, to a tactical asset, which means it's of real everyday use to the commanders in the field at the time. What it's also highlighted really is the need to have the independent source. So if you want to ensure that you've got this data at your fingertips, particularly in a time of crisis, that's often the case that the only way to ensure that is to make sure you've got your own satellites, your own constellations. And that has driven a huge demand worldwide, in fact, of interest and indeed contracts for ICEYE in customers, typically governments or companies that supply to governments, in having their own satellites and their own constellations. And ICEYE has been ideally positioned to supply those customers, not least of which because we have the only small, low-cost, high-performance radar satellites available in the world today. So it's been a real benefit to ICEYE, and we've really highlighted the benefits of this capability.
Okay, thanks, Steve. So building on really what both of you've said, Paul referred to resilience, this way of getting governments to embrace the convergence of both their own capabilities in terms of the assets that they've got in space, with those of the increasingly proliferated commercial operations of different satellite operators. Steve, I just wanted to pick up on something you were referring to there, which effectively I think is sovereignty and the increasing need as part of this requirement for resilience, not just to be able to plug in to these commercial operators, but actually to look to procure satellites from operators such as ICEYE. Would you mind just kind of expanding on that and just helping the audience understand why governments are wanting to go in that direction rather than just buying imagery from the satellites that ICEYE operates itself?
Sure, yeah, it's a good point. I think for quite a long time it was assumed that the model, which was often referred to as a service, something as a service, was going to be the way everything would go. I think the Ukraine crisis has really highlighted that actually isn't the case. And it's not the case for a number of reasons. If you are a satellite operator, as ICEYE is, and you are selling your data around the world to various governments and commercial organizations, as we do, you have a list of customers, and you have a priority list of customers, so you are a customer in a queue. And if you are down at some point down that queue and you need your data urgently for whatever reason, you can't necessarily guarantee you're going to get it. So the only way to actually guarantee that you're going to get what you want when you want it, without question, is to have your own satellites. And that is particularly relevant when you do have a security or defense crisis like we see in Ukraine. So it was absolutely the case that it highlighted to governments around the world that you have to have your own kit. And that really has driven a huge demand in interest around the world.
Thanks very much. So I'm going to switch gears slightly here and turn our attentions to the US. A number of different areas to touch on, given some of the events in the last 24 hours. Where I wanted to start, though, was understanding your perspectives as European/UK, whether we define UK as part of Europe or not, European companies looking to sell into the US Department of Defense, which by virtue of its scale is inevitably the largest single potential customer for any satellite or space-related company. So Paul, what's been ALL.SPACE's experience of trying to get into the US market as a foreign player?
Well, there's two key things to pull out here when you talk about working with the US DoD. And I currently still work with the UK MOD to help look at how they are applying themselves to the markets as well. The first one is security. The US DoD have stringent security regulations about not only the use and execution of technology, but also about which companies that they will use and which companies they will buy from. And that means you have to meet their regulations for not only where the products will be manufactured, but also where the supply chain of all of the parts and all the electronics and all of the sub-assemblies come from whenever you build a piece of technology to sell to the US military. Because what they don't want is any infiltration of any way of equipment that will be put on the inside of the communication networks that you'll provide to the US military. So you have to be able to melt and build into the regulations that would, implement a capability for the US military. What we found, and it's been fascinating as we've gone on this journey, is that the US DoD is constantly scanning for new technology that gives their warfighter an advantage globally. And the innovation that was created from ALL.SPACE's capabilities so that you could simultaneously connect to satellites in any orbit meant that as they were trying to find their strategy to solve that proliferation of global space bandwidth, they searched the planet, looked at every phased array company that was out there, and I have to say there were two main competitions, one for the US Navy and one for the US Army. And in both cases, they chose ALL.SPACE. And there's a very particular reason for that, because no matter what the marketing description is by any other phased array company, we are the only company on the planet that can do two simultaneous full beam connections to any orbit. Everybody else can implement it in a different way, but we did it. And therefore, our experience of working with the US DoD was actually turned into a market pull rather than us having to push. We therefore have been on the inside of the US DoD's contracting, and they have been developing with us to help us make sure that the equipment not only meets the regulations, but meets all of the network connectivity and software capability they require for the network architecture to deliver that capability. And we're now on contract and we're delivering products to them in the real world. And they're still paying us to evolve through the next generations of this to keep it going.
Great stuff. So the key takeaways there, I guess, that it is possible as a non-US company to sell into the DoD with probably a couple of important caveats. You have to bend to their requirements, and you have to have globally best-in-class technology to do so. Steve, keen to bring you in on this point and understand what ICEYE's experience has been of endeavouring to serve the US government.
Right, yeah, very, very similar. We spent a lot of time going through the compliance and regulation requirements in America to get certified, if you like, to be a supplier into that market. We set up in America. We have developed a US supply chain. We've got US individuals, even down to coding software in America for the satellites. So we are now building ICEYE satellites in America using that American supply chain and American people for the American market exclusively. And that has its It's not easy, it takes time, but once you've done that, you do then get, I think, a lot of the benefits that come from what essentially is the largest market in the world. And as Paul has alluded to, the US DoD is always on the lookout for what is best in class and capabilities they can't get elsewhere. And that is absolutely the position ICEYE has. So it's been a very, very useful exercise for us to do.
Great stuff. So I think we're coming towards the end of the discussion, but a couple of final points I wanted to wrap up on. I don't think we're going to get away without at least getting some indication of your very initial thoughts on what the outcome of the US presidential election means. So, Steve, starting with you. Appreciate, it's still extremely early days, but what is your immediate reaction about what the re-election of Trump is going to mean for the global space sector, but I guess also specifically for a company like ICEYE?
Yeah, so I think it should be evident to everybody that there will be an increased focus on defence and security, particularly in Europe, and particularly when you think about NATO. That was obvious from when President Trump was in his first term, and now he's coming back. I think there will be an increased focus on that and the requirement for Europe in particular really to put some emphasis on its collective security and defence. Now what that does is just increase the market, increases the opportunity, and I think we're going to see that increase and grow for at least another decade, maybe even more. The world is in a less stable place than it was, and that's going to persist for some time, I think. So I think we can look at this as an opportunity for growth.
Thanks very much. And Paul, what's your initial view on yesterday's seismic results?
Very, very much the same. I think given President Trump's previous statements about where he sees NATO needing to stand up and invest into the different capabilities that they have, and a minimum of 2% of the GDP. When you look at that from a Ukraine perspective or a security on Europe perspective, Europe now absolutely has to make sure that it has its own defence capability and it's got the capability it needs to look after itself as a member of NATO. Now, clearly, I don't think America is going to walk away from being a part of NATO and being in a commitment of that, but we have to make sure we did all of the things that made sure it's a cohesive and European invested capability to defend Europe as its own entity. And I think that's therefore going to drive investment. Defence is therefore, I suspect, going to see investment increasing over the next few years, certainly from a European perspective. The other thing that you allude to there, of course, when you said about the satellite industry, is what I was talking about from the LEO network constellation. Whereas Elon Musk's vision, has created a lot of debate about where the different satellite industries are going to go with a really powerful LEO capability. Amazon, Kuiper, and Telesat Lightspeed are therefore going to add to that. Our part in that, in creating ubiquity, access to all of the market, is we work with them rather than trying to compete with any of those networks, which enables us therefore to provide a pathway for other people to get access to those networks. That's, I think, going to be useful for European defence companies, but you also have to work very much with the US marketplace too, because they are the leaders in so many different technologies with the amount of money they've invested and where you're going to take that.
Great stuff. So then final, very quick comments from both of you. Crystal ball gazing over the rest of this decade, what are some of the key trends that you think our audience should be paying attention to in the context of space?
Satellite communication, things like PARP, which is a fantastic opportunity, are going to become more and more ubiquitous in every device. When you think about Internet of Things, the IoT, when you actually have hubs that can connect to all of the new proliferate bandwidth that's going to be available in space, what you will find is more and more devices and more connectivity will be available everywhere. So that means if you can imagine connecting any device, any electronic communication device, be it on a linked Wi-Fi network through to a satellite communication system or direct to a satellite communication system, it's going to change the way we think about connected data. So if you think about where data has changed everybody's life in the last 5 to 10 years, that's going to accelerate when any device can be globally connected at any point in the future. So whatever you want to use for your imagination of how this might go, I suspect it probably can do. And that's going to be an interesting investment platform for anybody who therefore gets connected to that in the next 5 to 10 years.
Thanks, Paul. Exciting stuff. So, Steve, over to you for final comments.
Thanks. I think I'd pick up on the proliferation of the data that Paul's mentioned there. The number of satellites in orbit now with sensors on, looking at the Earth observation, it's often called, the different types of sensors, that's only going to grow and grow and grow. And that means that the insights that we can understand about what's happening on the face of the planet are just going to get better and better and better. And we've seen that with ICEYE success in the particularly in the civil market with insurance companies and so on, with flood insights and so on. That's just the very beginning. The more data we get, the more analysis that's done on that, the more things we can find out, the more value we can create. So I think we're going to see a continual increase in the number of orbital sensors and networks, and a huge increase in the amount of analytics and solutions and understanding and information and knowledge that comes off the back of all of that data, which will drive additional value and revenue.
Great. Well, thanks. I think we're going to wrap up there. So just extend my appreciation to both Steve and Paul. I think that was a really insightful and interesting discussion. So thank you very much for your time.